Hey everybody, this is Brad Dyke reaching out to you, and today we're going to talk about your lab. I got a couple people asking questions about what can get you when you're dealing with your power and your distribution for your racks. Well, you see, the nature of racks is that you have what is called your power source, preferably two separate breakers, 20 amps each, and they afford you the ability of being able to put a decent load between the two of them and balance them so that you're able to accomplish what you want when it comes to the ability of distributing balance and power of your systems. That's why, hence, I've got 40 amps here, 40 amps there on these two racks back here, and 80 amps total, which I think is a lot of power. But I also have a separate 20 amp breaker to run the HVAC system to keep this comfortable temperature in here in the lab environment while I'm doing my work, even though it's negative 10 degrees outside without a wind chill. So you ask the question, okay, can I just, I'm building my stuff from the basics, and don't have a lot of money. I have some basic, I've got surge strips and splitter sets, and maybe these cool little 2-to-1 ratio with maybe a USB port on them or something like that. Can't I just build my own power solution that way and just pigtail these $6 Kia power strips together to give me all the connectivity and power I need, ranging to AC current? And well, the answer is no. In a nutshell, this is more like a mechanical surge strip. $6. It's got a basic pilot fuse assembly in it. When it goes, it kind of goes. But the bad news about such basic and simple designs as these is that they can carry over. That's not something you see in a conditioned environment and so on. But before we talk about that, let's talk about some other device connections you can have for your alternate current connectivity, i.e. plug-in sets and so on. And that is, you have these what we call travel matters, and I've seen people do this. They'll take like 10 of these across 4 basic surge strips, and they get themselves 20 port connections, 10 on 10, based off of the 6-port bridge connection, or that's how they think they can do it. And the end result is pretty disastrous. These aren't really designed to protect your system. They're just simply designed to split the power out to 2 receptacle heads, and they got a small USB, AC output, DC, connection bridge regulator in there, designed to allow you to have the necessary DC voltage you need on a USB cable to do a fast charge. Most of the time, it's only a single amp, so that means it takes forever anyways to charge anything on it because it is antiquated. But you also have what we call multiphasic style devices that might have, multiphasic means you're using it for more than just one thing. It could be like a phone line set, a network connection set, surge set, and you can bring in your coaxial in and coaxial out. And this device, as long as that LED is working, it's an intelligent device and it's functional. But there is a trick. Only one of these on a circuit. That's the trick. I've seen a lot of people put a bunch of them on, and they expect them to work right, but they actually can create some issues on your power, which can cause everything on that circuit to blow, and you don't want to do that. So with that being said, let's talk about power and how do you get it from the simple one output connection from the wall into a extravaganza style footprint like you see here with this stylistic surge strip, which is also known as a PDU distributor. And I have another one right here. Now, there are many different terms for these, and as you can see, I have different kinds of, I call them legacy designs. But these are high-end, high-core, true strips, and they do exactly what they need. Now, with this configuration, it's only recommended to put a single strip unless you have them separated by circuits. Now what does that basically mean? Well, here you can see I have what's called a 1U footer power strip. This one is PC rated. It's a good design. I'll talk to that in a minute. And then up here I have a low end single surge strip, just one single surge strip that is plugged on the second unit that is running separately from this guy, who is of course separately plugged in to their appropriate homes. So with that being said, I've distributed correctly how I want power to be on this environment. So what does that mean? Well, let's go to the basics, okay? You have what's called alternate current, AC current, alternating current, that's what we call it. You also have direct current, which is DC current. And DC is applicable to devices that want direct current feed load, opposed to systems that have the ability to handle alternating current. Now that's pretty much in a nutshell. You don't have to be an electrician, but if you were to be, let's say, wanting to learn how to understand how wiring works and how you should properly distribute power feeds and so on, I'd recommend Lowe's using the Basic 101 Electrics Guide book. It's red, it's elongated, it has a little hole in the end where you can put a little hook on it, and you just put it in your car. Whenever you have a question, you pull it out, and you're working on something, or you have a question about something you want to do in your house and so on. It'll teach you the basics, but you don't have to be an electrician. You just have to think. First things first. Simple household analog style voltage basic, that's what we mean by analog devices such as this that you can get at IKEA, Walmart, and so on, run about $5, $6, $7, $8 a strip. Looks great and awesome, but it's a mechanical switch setup designed for a very rudimentary function. Pilot style fuse assembly release. That's it. A very basic popper, and when it pops, it's what we call dirty. It can kick back some sparks and stuff like that, can cause some problems behind the fuse assembly that it's not supposed to do, but cheap is cheap, and that's what you bought. You bought cheap stuff. Now, there's another kind of surge strip out there, and you saw it in my rack, which is a PC rated surge strip. These surge strips come with an insurance policy by a company like Tripp Lite, APC, and so on, and they actually look pretty sophisticated in comparison to the basic generic analog style surge strip. These are also, and many times, PC rated surge strips will have a little bit of intelligence in them that helps regulate and protect your systems better, but it's only one step up. Now you can also get yourself what we call a mid-bride or an intermittent insert that has a small breaker solution for like a 15 amp output plug-in. The 15 amp is, by the way, is the fact that you see how this connector is set up. A 20 amp has a T or a little cut in it that looks like it's one normal and then a T and then the ground. Now these are great, but they're only designed basically for the two-prong output. When you add a surge strip to that as follows, kind of be careful, okay? You're using advanced logic, but then you've got the dirty spark in the back, so this can still blow on you and can give you some problems. Your equipment's expensive, and you're doing it on the fly on as low cost of expense as possible. So I recommend that you take a little bit of time and invest in the power side of the equation. The next thing we have up from a PC rated surge strip, by the way, those only run like $10 to $15 a strip. The nicer ones with like a $25,000 policy on them clear a little higher to like $20 a strip. The next one is called a line conditioner. And what a line conditioner is it's using a series of capacitors or even an intermittent battery style solution to break the alternating current from the wall to a very short few second hyper zone of power that powers whatever's beyond it. Now, this is very important when you're dealing with a line conditioner. They're rated for so many watts. And because they're rated for so many watts, they're only going to do so much. But they're excellent if you don't want to spend the money on a UPS. Uninterrupted power supply style protection is the next logical step from using a line conditioner. Many times people will use a line conditioner in front of, or a PDU style line conditioner on front of a uninterruptible source of protection, such as UPS and so on. But the line conditioners are great just as they are. They just have a little bit of what we call a buffer between the wall power and your systems. Now, why is that valuable? Okay, something that a surge strip cannot do, even a PC rated surge strip, they can't truly protect you from what we call a static discharge. A static discharge, as I have learned unfortunately many times, is usually a result of a lightning strike not anywhere near necessarily your house, but within your community. When lightning strikes, it creates a polarizing field of static electricity, which means it's going to travel and it's going to move through your environments. And the nice thing about line conditioners is they will ground out your networks, they will ground out your coaxial feeds, they can ground out your phone lines if you still have a landline, as well as your power. And by doing that, it gives the static dissipation effect of lightning strikes a place to go, opposed to trying to travel through your equipment through the line conditioner into the neutral ground of the house. So what you do is you use a line conditioner style device that can give you the ability to plug in, very much like you see here. They have basically different kinds of port interfaces, RJ11s for telephone lines, RJ45s for networks, and so on. And all it's doing is helping you dissipate the functional charge. Now, with that being said, now you're talking the big boys. UPSs and PDU distribution units. PDU distribution units are high quality surge strips that have some digital intelligence in them that can go as high as remote administration power cycling processes by individual actual AC ports. Now these look exactly like the ones you just saw on my back of my rack, except they have their own internet connectivity, and you can have a cell phone built into it if you want for a hotspot, so that you can remotely go in and go to that specific port number of that specific server and say power off and power back on. These are high intelligence digital baseline systems that run a specific amount of cost in the process. Now, we've talked about plugging up power cables. And when you're working with power cables, and the nature of power cables, you have your standard R15 style setup, and your PC back in, plug in. But now, let's talk power, batteries, UPSs. There are basically three classifications of UPSs. We have what's called the basic PC UPS and digital appliance type style UPS. There are a lot of acronyms involved here, so you have to forgive me. So with that being the case, you have to also remember one other very important detail, and that is how much coverage do I need? Well, a UPS is designed to take the alternating current from the wall, put it into a AC-DC conversion process, and power it into a battery. And then from there, the converter process of reverting it back to AC current on the other end, where there are 4 or 6 or 12 or 15 style connector heads that would allow you to connect your PDUs via by plug, and the power distribution units is what we call PDUs, and those will usually have 10 to 15 R15 style plugins. And there are many different versions of R series 15s. This is I just use the generic term to make it easier for everybody. But as far as everybody's concerned, when we think of 15, we think of a standard 15 amp style 3-prong plug-in, American style. There are different styles for other European countries. I would refer you to those resources to determine what those are. But the UPS requirement that you want to make is based on a mathematical equation of adding up the output of your power, your requirements for what we call the recovery stage, and then of course intelligence between the UPS and its devices, so that they know, I've lost power, you need to start shutting down. This is what we call the recovery period. And the recovery period of this process is where the intelligence from the UPS has told the device or devices, through either a USB cable if it's a small system, or a RJ45 style network announcement coming from the UPS to all devices on the surge strips or the PDUs that are connected to the UPS to begin the process of shutting down gracefully. And now you're recovering from the loss of power, hence the mindset recovery period. So, with that being said, if you buy a small UPS and you put 15 computers on it, it ain't going to work. It's going to go boop, about 2 seconds after it loses power because the drawing current is too high. So you have to do the math. You have to say, okay, how many watts am I going to need? And there is actually, usually on the back of the power supply, you'll find the wattage requirements of a PC. You can also use what's called a watt meter. You can plug the watt meter in. It kind of looks like this, but it has a small little LCD display here that tells you how many watts the unit draws. And laptops, computers, monitors, everything you think you need to have power long after, I would say, at a minimum of 15 minutes max after the loss of power. So, the UPS, how much wattage are you going to need? What does that look like in a UPS? And how big will this become? Very important, because you have to plan for the placement of your UPS in your solution. Now, I have what's called off-on strategy. In other words, I use advanced PDUs with digital communication, but I choose not to use UPSs because I'm in a PC lab that belongs to me, and it's a lot of money, thousands of dollars, to be able to protect these systems if they're all up and running, and I just don't work that way. I work in phases. I bring 5 up here, 6 here, 10 there, 4 there. I can technically bring almost all of this online at once if I wanted to, and of course my dial on the power indicator is going like crazy because I'm drawing 60 amps, pretty much hardcore, but I don't necessarily need the UPS. But if I did, I would do this. If you have something that emulates a PDC, that's a primary domain controller, or an LDAP controller, or any equivalency of Active Directory services, I would suggest that you set that guy aside. One of them, not all of them, but one of them. Usually in a lab environment like this, you'll have 2 or 3 to represent like 3 regions and so on. With that being said, it has to be a physical controller. The controller holds all of the SID accounts for your systems, your test groups and all of that. You don't want to lose that. It's kind of a pain in the butt if you have to rebuild all that over again. So you put one of those physical based controllers on a UPS. You might have an email system and an infrastructure, i.e. a parent switch, like I have with that top 10 gig switch. And the domain controller, the primary domain controller, in this case for Active Directory services and my LDAP test, go to that top switch with my SMTP emulator, and that's it. Now that's 3 units. I'm going to roughly generate about 750 watts. So a 1000 watt based unit, and I usually prefer to use either Liebert 1500s or APC 1500s, but be careful, and I'll explain this later. Make sure you get the proper wattage output. That's a little trick that a lot of UPS companies are doing these days to try to make profitability by not truly saying what they're doing. I'll elaborate on that one later. But as I was saying, the key thing here is not everything has to be on a UPS, and most systems today have the ability to recover from loss of power without loss of data because of NVMe, SSD style writing processes are so fast, unlike the old days of spinning disk, that it writes quick enough before you lose power. So that's good. Not the case for disk arrays and so on and so on. When you bring disk arrays up, you want to make sure that they have some type of protection as well. Now, with that being said, with that being said, the last thing you want to consider is what you would call monitoring or intrusion processes. Like you have a NetBot camera set up in your room, or you can quietly monitor the environment, or you have a sniffer set out there that's listening to your network traffic and so on independently. Or you have a pfSense platform, another example. Those usually should require their own individual UPS, and they're usually low wattage, so about a 500 watt UPS will do just fine. APC has a small little unit that's about 16 inches long, about 8 inches wide. It's a small compact thing. goes in the back. It will do you just fine. It will run a nice little blade server for that requirement, or a small form factor unit that just runs a few hundred watts, and you're in great shape. And at that point stage, you've covered your base with just basically two UPSs, a 1000 watt and a 550 watt unit. Now, with that, those are the basic units that you can get that stand up kind of like a tower. It will stand very much like a PC tower. In the back, it will have its output, input, and it will have, of course, the outputs for protected power, but they're not very big, and usually the other type of UPS is much smaller, roughly about the size of this much of capacity, size-wise. It's not very intensive at all. Now, that is not going to be the case with this next UPS style system. We call them SUPSs, Smart Intelligent UPSs. They're designed for the enterprise environment, and they're designed to interact with PDUs as well. This is what we call the creme de la creme. And they're very sophisticated, they're heavily licensed, and I'm sure a few of you, professionally wise, have come across these. These could constitute an entire rack. Nothing but batteries and controllers and conditioners. They can also constitute the size of a 2U server or a 1U server, depending on their requirements. The key thing is they go into a rack and they work off of your localized networks in what we call a privatized VLAN style setup for UPS communication only. And what these guys do is they provide power for everything. Nothing rides directly to the wall. It has to go through the PDU, through a digital interface, into the UPSs that are intelligent. Those smart UPSs then in turn communicate back and forth and give statuses of health analysis, the harmonics of your power grid, and so on and so on. And it's a technical nightmare, in some cases if you let it. But a couple of my good data center buddies and I have put in these things, and I've seen the best and I've seen the worst and what's in between. Even though I don't work in that environment, building a data center is just that. You're building a data center from the ground up, and you have to touch everything. So it's a great experience. I don't recommend, unless you can get them for free, and you can replace the battery at cost. That's the painful part, replacing the batteries. I don't recommend it. It's overboard. Unless you're a data center manager and you're working what we call power distribution models, that's the only thing I could justify having such sophisticated equipment in a local lab. So what I do, if I do, I basically keep it simple. I use my PDUs to the walls to afford a very nice functional protection on all fronts but continuous power. I can get away with that. So can you. Learn to turn things off, save the power, don't leave them running constantly. It's okay. This is a learning lab. It's not a 24-hour operations center. If you are doing that, then I would say make yourself localized, take your local NAS, which is a small device, hopefully, like I said, your email services device, if you're doing communication, your LDAP or your Active Directory or your domain controller kind of configurations, a couple of small UPSs, segment them away with their own search strips, and preferably conditional line strips, and you're okay. And then put everything else on a basic PDU. You can get PDUs really well. Matter of fact, Harbor Freight, yeah, I said it, Harbor Freight actually has a really well-rated strip that affords a clean separation. It's good. I mean, you can use that with a nice like a front-end breaker set like this, or a receptacle unit in the wall that has the breaker set built into it too. Also works. So that's what we're going to get into next. We've talked about the cheap stuff that doesn't work, the stuff in the middle that kind of works but can get you in trouble if you don't do what they say they can do and you try to make it do more. Then we talked about the real stuff, such as line conditioners for professional style systems, which work really well for your lab, to PDUs, power distribution units, and UPSs, both simple, medium, and enterprise-based smart UPS systems. And then you have what's called the rest. What is the rest? Well, you can actually Let me see. Yeah. Hang on a second. I'll get you what I'm talking about. Okay. So what you can do if you've got a what we call a trusty little drill here, you can actually get a little sophisticated and simplistic at the same time. Now I showed you guys earlier like a line conditioner style prong set. This is a great little one. It's called a Microgest power unit, and I don't think they're made anymore, but they're a little rare on capacity because you know they kind of come and go. They're so good they put themselves out of business. Let me reach over here for one more thing. Okay, so I have now what I need. So what we basically have is the special stuff, and I've actually used it and I've been impressed with some of it. So the very first thing you can do is you can put PC quality surge strip equivalencies into your receptacle box itself. That's this. So this is a 20 amp receptacle. You can see the difference between it versus a 15 amp plug. There's that little T I was referring to. Now, this guy does 15 amp output on a 20 amp circuit. This guy does 12 amps on a 15 amp circuit. Why? Because the wire in the wall may be a smaller diameter. And when you're dealing with a 15 gauge wire that is designed to support a 15 amp load, it is not a very large wire. And that allows you to be able to save on costs, basically. So lights, fans, things like that don't need high amp power. You got to be careful. When you run 20 amp lines, you're on 12 gauge wire. And that's three basic wires, black, white, and green. And there are a thicker wire designed to move more power over the actual power of the surface of the cabling itself. And that way, if you ever have a 15 amp socket and you try to put 12 gauge wire in it, it won't take it. Because you see on the back side of your electrical switch, I'm sorry, not electrical switch, but your electrical plug. The plug is the female, by the way, or receptacle, opposed to the plug, which is, this is a plug, this is a receptacle for the plug to go into, male and female. So, but if you look on the back of this, you have what's called insert points. And the proper gauge wire for it will insert correctly. Now, yes, you can put a 15 gauge wire on this guy, but you put your hand on the wire when it's pulling a 20 amp load, it's hot. It could actually catch on fire. Hence, be careful. Think out your payloads for power and use it equivalency. Don't put a receptacle like this on a 15 gauge wire. Bad idea. But with that being said, the good thing about these is it's keyed. It has one guide going this way, one guide going this way, and a hole. So you can't really put a heavy hitting receptacle in this if it was a standard 15 amp output like this. It wouldn't fit. That's your protection. Now, can you just cut the heads off, put something like this on instead, where you have high powered lines, but you're going to a standard receptacle? Yes, but at your own risk. It's a violation of electrical code when you do that. This receptacle set here is for 15 amp based wiring port, and that means both the kind of wire you see in the walls and PC wires. A lot of people will cut these guys off. They'll have a T on the end of them instead of a standard 15 amp plug. They'll cut that off and they'll put one of these on to try to power their stuff. And not a good idea, because your actual PC cord will melt. That's bad. But back to what I was saying. You got a wall socket, right? And you put in that socket a PC set style receptacle head. And sometimes it can be just the single port with the second port having LED indicators down here, and you're plugging a single connector up to this. You're saying, wait a minute, what's the value of that? Well, that's not a problem. You see this guy right here? he's got 2 outputs. All right, so I can plug him right on in on that single port, and look, I got my 2 outputs. And this is better, by the way, because you can tape and secure these where you can't do it here. So, but anyways, you can get those. Now they're about $30 for one of them, but they do an extremely good job for everything except for one small detail. Let's say you take a hit, a lightning strike. It was a half a mile away, and it hit and it blew this guy out. This guy did its job. Just like all the other devices, including this, these get burnt and fried. They're not usable anymore because they did their job. They were a surge strip. They were designed to take the hit instead of the equipment behind it. Same effect with this guy. Now, I do like doing this, but I'm also very careful how I do it because you put too many of these in and you have a really bad storm. That's a lot of rewiring you're going to have to do, and you've got to take every one of these off and replace them with new units. Now, it would be easier and better if they had a plug-in socket module that you can just simply pop out, take the fuse assembly that gets blown, and put a new one in and keep going. That's a tip for those who are listening to this kind of stuff. It's not a bad idea if you want to introduce a new product to the industry, because it would work. Now you also have another gadget which is very much like the receptacle, but it is basically like this, and it has a series of LEDs on the side, and it's PC rated and has insurance on it. Basically, it's a different form of a PC rated surge strip that goes on the wall, and you can use only 3 out of the 6. That was my recommendation. But you go here, here, and here to distribute the workloads across that wiring, so if there is a heat up, this box will not catch on fire. But the key thing is you have the surge strip style strategy that's PC rated on the wall. If it goes bad, you pull it right off, because it goes right on the wall socket, right, like that. And as you can see, it's connected, and then pop it off. This guy is fine, there's nothing wrong with him. Put a replacement unit in, off and go. It did its job, nothing got damaged, and you did okay. And that's really what I call my recommendation to all of you starters out there. Start that way. You'll find 1 or 2 of these on the wall, and there'll be 15 amp outputs. Spend the $30-$40 for a couple of these. Put these on top. They are usually pretty well rated, not to go beyond spec, but I like to just play it smart, and I spread my connections apart like this. And remember, these R15s are just that. So you get a couple of these, which is basically a single to a splitter, and you plug them into here. 3 times 6, that's pretty dog. 3 times 2 is 6 outputs. That's pretty much a good match, right? So not to mention you've got good distribution and you're handling it right. So that leaves the last other thing, and it's, if you're brave, you might want to consider this. And usually only for things that draw power, like a storage array, or a UPS grid or something like that. And that is the surge arrest plug sets. These are harder to find. They're kind of difficult, but they do exactly the same thing as the upper echelon PC rated surge strip style setup, but it's only for a single output. Either end can act as it, just depends on what they buy. They're like $50 a head. They're not cheap. They do work. You want to customize the wire that you put on them on the backside as you put the wire in. Make sure it's properly rated for what you want to accomplish, and by doing that, you have yourself a one cable line that's ultra protected, and it has to be, because it's the keys to the Cadillac. I would say a blade chassis would be a good example for this. What I mean by that is, in the older scheme of things, like a UCS or a Dell blade chassis, or like an RLX platform, you'll have a large chassis with 2 plugs on it. And you'd want to customize those hookups so that they have the proper power with the least interference, and don't share it with anything else. It's a lot of output. Usually a 20 amp receptacle head is what you're doing here, or a 30 amp receptacle head, same thing. They plug up to the back of the blade unit, and that line is well built. I mean, it should be, because that blade server has 25, 30, or 40 virtual servers and storage and everything you want. You want to make sure that you do that process well. And of course, when you have such a device like a blade chassis, you're in a special class of lab, unlike the poor man's version, where we build our blades by smashing PCs together. A blade chassis is the lower ends are 20 amp circuit style outputs, which would be like an L620 versus an L630, which is the alternate version. And you're dealing with a 20 amp power bridge or a 30 amp power bridge, but it's usually coming off of a UPS. So when you're dealing with the last part of this discussion, and that is high power, let's say you inherited a bunch of stuff from an old data center, and they're full racks, and you got one rack and it has 2 L60s or 2 L30s in it, and you've got to be able to protect it because it's your complete set for 30 PDUs on each side. So that means 60 receptacle plugs you could plug up for like a whole bunch of disk arrays, like an EMC disk rack, or a NetApp disk rack, or an IBM, or one of the manufacturer's style standards. You would have what's called usually the equivalency of a UPS 3000 series, which has the back panels for an L630 or an L6, a 60 amp load, 30 amp loads, and so on. And they're not small. They're usually, if they're rack mount versions, you've lost 8U of your rack to do that, because you'll have the controller set, and then you'll have the actual battery enclosure too. They'll be stacked on top of each other, or one underneath each other. Or you can have what's called a distribution panel, where those are sitting there, which would be side by side. So you could have a distribution panel on this side, those special cables I was telling you about, that you connect from the UPS side over to your blade chassis, and then you have 100%, the best you're going to ever get. Even if you had a direct hit on the house, it would be really hard to fry your equipment on that kind of a footprint. But last part of this whole thing is, look, Mother Nature is fickle, and I plan, and the weirdest things happen. One of the bad ones has been Wi-Fi. A lot of the devices here have antennas in them. They're embedded in them, in the laptops or in the back of the chassis or in the small form factors. That is an Achilles heel, because no matter how well you plan all the wire that comes in and out of your systems, you have a problem with airborne radio wave patterns that also can be vulnerable to static discharge. And so the equipment gets fried from the other side of the equation, from its Wi-Fi side and or Bluetooth side, because those are open anodes, or basically data endpoints, where you can connect an antenna to it, and that antenna is what causes the vulnerability. The basic thing is, if you don't need it, don't have it on it. Don't have the little antenna on the back of your server as an alternate pathway. Use another Cat5. It's better that way because you can completely ground that out. I like Wi-Fi. It's cool. It's great. I use it all the time. But I lose a lot of Wi-Fi equipment over time because they're just so sensitive to all the energy in the air. So, remember that Mother Nature and the way it works can take best laid plans of power distribution solutions and lay waste to them, just to prove that, hey, it's better than you. So this list leaves us to the last part of this, and that is, how do I know what to buy? Good question. And the answer to that question is, in 10 or 15 years ago, it was really easy. You did the math on how much wattage you want. You put your math in the math equation set, and then the company will then turn around and they will say you want a UPS 1200 or 1300 or 1500 or so on and so on and so on. And the prices were pretty straightforward because having them being straightforward meant that the market was defined. But about, I would say, 8 years ago, other companies came in and said, how can I undermine the way people buy UPSs so they can buy our stuff? We look like we can do 1500 watts, but we can't really. But we can make the math look like it does, but we really don't. And you have to do the math. I call it double stating. They'll say I have an ADL 1500 series 12, and it's like, okay, that sounds like a 1500 watt power supply, right? I'm sorry, UPS supply, right? No, it's an 850 watt power supply output that comes from the central part of the UPS, but they give it a title like it sounds like it's a 1200 or a 1500 like the big boys, and you make the mistake because we've been buying them in that standard for so long that when you finally get your box and you look at the fine print, it says, well, we can only do 800 watts, and our warranty is pretty vague, and good luck trying to return the UPS. It's almost impossible. So my professional recommendation, even for labs, stick to the true and tried. Liebert arrays, UPS arrays, APC UPS arrays, smart intelligent version, that's at least a UPS cable connection or as high as a network connection. Lieberts are very good as well. I do endorse them. I use them on systems I want to keep up and running no matter what, and they're very resilient. But a lot of these no-name companies really are doing everything they can to try to take the market shares away from these well-established, high-quality solutions that you can actually get pretty cheaply on eBay, and then just spend a little money on replacement batteries because you got the quality of the hardware inside the units. I have seen some really poor quality in some of these cost-minded solutions. I really have. Not pleased with any of them in any way, shape, or form because it's junk. And even when you try to read their doublespeak, you can still make errors. So if you're not sure, jump out on the internet, ask some questions. It never hurts to check twice before you buy once. It's a piece of advice on my side of the discussion. The last thing is quality matters when it comes to power, because if you don't do this right, the one true thing you don't do right could cost you all of it. In the past 3.5, 4 years I've been doing videos, I've not had a problem. And most of my stuff I bought on eBay is recycled gear. So you can get the high quality stuff. You can even have some pretty cool fun with it and play around with it and things like that. But the key thing is, just because you think I want to buy a new unit but I want to get as cheap as possible, be careful where you go with that, because you're not going to like the end result. Well, I wanted to talk to this because they were asking me to talk about this particular stuff. And I am interested in other things that you guys would like to know about as we go into 2024. And the weather's been cold, but because, as you can see here, my gear is running. So because it's running, I'm sitting in a pretty comfortable room, even though on the other side of these walls, these Class B walls, I am looking at some really cold weather out there in Ohio. I mean, it is brutal. I mean, we had almost 20 degrees negative out there with a 35-mile-an-hour wind. Not pleasant, let me tell you. But this is Brad Dyke. I'm going to sign off. I hope this was something good for you guys. It's a little bit off topic from some of the other things we talked to, but this is about you guys getting your PC labs in a good place, in a good way, in a good standard, so that you could have fun, reinvent, get outside the box, look inside, what you were once working on, and see, hey, I could do totally different things. At that point stage, I'm going to go ahead and let you guys go. You take care, and God bless.